Welcome back to lesson 14. We're going to talk about evaluation of algebraic expressions. Basically, that means we're going to introduce variables at this point. And a variable is just a letter that we use to represent a value within an expression. An expression is a set of numbers that we use to express a value. And an algebraic expression is one that includes variables. A numerical expression is something like this. If we said 7 plus 2 minus 3, this is a numerical expression because it only has numbers in it. Whereas a algebraic expression would look more like this. It has a variable in it, and that variable is going to be a lowercase letter that represents some type of or some value. And we don't know what that value is. It's an unknown value. That's why there's a variable. We're trying to figure out what that unknown is. Or we want to substitute in different values for that variable to see how it affects an outcome. But whenever we have one of these terms, and this whole thing is an expression, that's something that you're going to want to write down. It's mathematic language and terminology that's important to remember. So the whole thing is an expression. One part of it, like this, that's going to be called a term. Okay? So one term, and all together it's one expression. Okay? So in this expression, we have 1, 2, 3 terms and 2 operations. The little things that you have to do, add, subtract, multiply, divide, those are operations. Okay? And if you want to, you can call that out too. So you're going to want to draw this little diagram in your notebook so you can keep the terminology straight, because sometimes it flows together when you get to talking fast. You know, you start calling the whole thing a term or the whole thing an expression, but just having a little diagram will help you keep it straight. All right, so within this term, all right, here's our term. Our term is 4x. There are other words that you need to learn, and we've already talked about this one. The x, that is called a variable, and it's called a variable because that value can vary. And 4 is called a constant. And it's called a constant because it keeps the value of 4 regardless of what the value of x is. So it is a constant value of 4, and that's why we call it the constant. The value of x could be 2, so 4 times 2 would be 8. It could be 3. 4 times 3, that would make that 12. That would be the value of that term. We don't know what this is, so the variation that it could refer to makes it the variable. It varies. Okay? So those are the terms. Now, the other thing you need to remember when we have a term with a variable, that it is always multiplication going on between the constant and the variable. And it doesn't matter how many places is in the constant, as if it's a number, it is treated like a number. It's treated like a numeral. So this could be 14, right? It could be 14x. That's still going to translate to 14 times x. It's not going to be, let me use a better way. It is not 1 times 4 times x. This is the whole thing is a constant. Okay, we see it as the number 14, not 1 times 4 times x, but 14 times x. So it's not this, it's this. Okay, so the numerals written together is a whole number, and then whatever your variables are, all of that is multiplied by each other. So you have a constant times a variable. And if you have another variable, it's times that variable. You might very well have something that looks like this, 3xyz. It would be literally be translated and solved as 3 times x times y times z. If you had 23 x, y, z, that would be translated or calculated as 23 times x times y times z. Okay, so think of these as factors, and x, y, and z, the variables, they're just unknown factors right now. We don't know what values they represent, and that's part of the purpose of an equation is to solve to figure out what those are and to find our unknowns. Okay, so pause if you need to take notes. I'm going to clear the page. And we're going to do some practice problems. So our first practice problem is 14.1. And we are given 3 variables, x, m, p. And we are told that the value of x is 4. The value of m is 5. And the value of p is 2. So given what we've already discussed, what's the first thing we need to remember about x and p? It's that they're factors, right? And so they're multiplied against each other. So what would be a good way to put these in for these variables? We could use buckets, kind of like we do for our positive and negatives, kind of the way we did to hold those values in place until we could get used to them. So let's use buckets for this. We have x, we have m, and we have p. So x was 4, m was 5, and p was 2. So now it's clear by putting them in buckets that they are to be multiplied against each other, because we're used to seeing parentheses next to each other, meaning to multiply. So that's a quick and easy way to get it right. Just treat your variables like buckets and drop the value into each bucket that it goes in. So now we know 4 times 5 is 20, and 20 times 2, that's going to be 40, and that's the answer to the first one. Let's do another one. We have 14.2, and we are going to find the value of 4yz minus 5, and the value of y is 2, and the value of z is 10. And I like to put a little line through my z because my 2's sometimes look like my z's. That's why I try to put a little loop in my 2 so don't get it confused with that really ugly z that I just drew. Let me try to do that better. If you put a little something right there, then you know it's a z and not a 2. So let's drop them in. Let's make some buckets. So here's our 4, here's our y, here's our z, minus 5. So y is 2, and z is 10, right? So 4 times 2 is 8. 8 times 10, that's 80, minus 5. So 75 is our answer. Very good. So let's do another one. See, these are not so hard. The variables are actually pretty straightforward and fairly easy. I'm going to let you guys do 14.3 on your own. So the problem says y minus z, and y is equal to negative 2, and z is equal, let's see, what is z equal to? Z is equal to negative 6. So pause the video and work the problem, and then come back in just a moment and let's see if you got the answer that I got. All right, so if you took the time to do the problem before you proceeded to see the answer, you should have come up with a positive 4. And here's how we got that. We had y minus z, so I made buckets for y and buckets for z, or a bucket for y and a bucket for z. And then I took the value for y, which was negative 2, and put it in for the y. And then I took the value for negative 6 and put it in where the z was. And then I, after I filled my buckets, I simplified my bucket. So I had 2 negatives here, 2 negatives, so it was a pair of them that made a plus sign. And so then I just removed my buckets, my parentheses that made my buckets, and solved it. So negative 2 plus 6 is going to be 4, because the opposite sign, you subtract, and then whatever the bigger number was, that's the sign. So it was a positive 4. Okay, let's do 14.4. I think we can do it right here. I think I have room on my page. 14.4 says negative a minus b minus ab. So now we're starting to see some repetition. And a is equal to negative 3, and b is equal to negative 4. All right, so the first thing I'm going to do is I'm going to make a bucket. Now, we have to be careful with our negative signs here. The negative signs are not attached to, just like here, they're not attached to the variable. The variable is a value all by itself. So we make the sign, we put the bucket where the letter is. We make the sign, we put in the bucket, we make the sign, and then we put in the bucket. We do not assume that this is negative and this is negative so we can leave it. No, that is not the way it works. A is negative 3. Negative A is negative, it's the opposite of negative 3. So we drop in our values for A. This was an A, and this was an A. Right, and this was a B, and this was a B. Right, so I just went straight below and filled in the values. Now we look at what we have. If you don't remember that A is a value all by itself, and this is asking for the opposite of the value of A, okay? You can get confused. So make your buckets, and that will help you keep the signs straight. So now we see we have a pair here. So that's going to be a positive 3. We have a pair here. That's going to be a positive 4. We have a pair here. So that's going to be a positive 3 times a negative 4. So it's going to be a negative 12. Right? So 3 plus 4 is 7 minus 12. That's negative 5. And that's correct. All right, you see how I did that? You have to keep the minus signs out of the bucket. They're separate. You know, just because you have a minus sign here doesn't mean, oh, this is negative 3, it's negative 3. No, it's the opposite of a negative 3. So you have to keep the buckets outside of the negative. So let's do another one. Let's see if we can see that again. Let's do 14.5. All right, and we have another situation like that. We have negative x minus a negative a plus b. Okay, and x is equal to 2. A is negative 4. And b is negative 6. All right, so I want you to pause the video and work this problem, and then come back and see if you got the same thing I did. So your first step should be to make the buckets, okay? That's what you should do first. Make your buckets. Then you're going to put in the values for your bucket. So we have a 2 where the x is, a negative 4 where the a is, and a negative 6 where the b is. And see, I already have the signs that were there. I transferred them. We kept all those signs. I didn't lose any of those. I just put buckets in where the variables were, where those little letters were. All right? The next step, I wanted to simplify, so I first said the opposite of positive 2 is a negative 2, minus, and you had a pair of negatives here. So the opposite of a negative 4 is a positive 4, and then you had a positive and negative here, so it only takes one negative, so that's a negative 6, right? So I solved what's inside the parentheses first, and 4 minus 6 is going to be negative 2. So I have negative 2 minus the negative 2. Now remember what I said before. If you need the opposite of a number, you can put the 1 in here. If you still need to do that, then do that. But we know now, all we have to do is see that there are 2 negatives So -2, and this becomes a +2 because you have 2 pairs of negatives here. So -2 plus 2, your answer should be 0. Okay? All right. Very good. Let me clear this page and let's move on and we have 3 more practice problems. I'm going to write them here, and I want you to solve them. So 14.6, 14.7, and 14.8. Give me just a moment, and with the magic of video, I'll have them written up for you. All right, so here are those 3 problems, and here are the values you're going to sub in for each of those problems. So I want you to pause the video and solve all 3 of those, and then press play and come back and see if you got the right answer. Okay, so for problem number 1, you should have gotten -8. And we had -2 minus 3 minus -4 plus -2. We solved the innermost parenthesis here. The minus a plus x was 4 minus 2 because we had a pair of negatives, so that made it a positive. And we had a single negative here, so 4 minus 2 is 2. -3 times 2 is -6, so -2 minus 6 is -8. Okay? For 14.7, we had -m plus x times -a plus mx, and we dropped in these values. Now, if you notice for this problem, I made circles for my buckets, and the reason I did that was because all of those parentheses were becoming confusing. So if you want to, you can switch these outside parentheses to brackets and make these parentheses, or you can just use a circle or a box. It doesn't have to be parentheses like I did in 14.6. You see how confusing some of that can get? You can make a circle or just make a big, like a square, and drop your number into it in place of your bucket that you're filling the variable value. So do it in a way that makes sense for you and helps you to keep it straight. That's the most important thing. You don't want to have just tons and tons of parentheses to confuse you. And also another thing that I did up here was the existing parenthesis in the problem. I made those bigger than the little buckets that I used, but you can always use the big circles and fill those in, or you can draw a box and put your value into the box. Either way, whatever works for you, that's the way you need to do it in your schoolwork, okay? And eventually, you're going to get to a point where you don't have to make buckets. You're just going to put the numbers in, and you'll be fine, okay? All right, let's do the last one. Okay, so I got a little fancy on the last one, and I drew some cute little boxes just to illustrate that you don't have to use circles, you don't have to use parentheses, you can use whatever shape or container for your variable values that you want to. But my cute little boxes are, they're a little time consuming, so you might not want to go that route. But anyway, we dropped in a 4 for the value of x here and here, and we dropped in a -2 for the value of a here, here, and here. -4 times -2 is 8. And you could say 4 times -2 is -8, and then the negative, the opposite of -8 is a +8. Either way it works. 4, and we have a pair of negatives, so that's 4 plus 2 is 6. And then we have plus a -2, so that's just -2. So 8 times 6 is 48, minus 2 is 46, and that is the correct answer. All right, that is all we have for lesson 14. If you want to get creative and practice making up a few variable problems and picking a few random values for them out of the air and just subbing in, that's really great practice. That'll help you do that well. Please do the practice problems for your module. This is all I have for lesson 14, and I'll see you in lesson 15.